What's up, guys? So let's solve this 1414. Find the minimum number of Fibonacci's whose sum is k. Okay, so this problem is interesting, and the answer is not difficult. But if you want to rigorous prove this is true, it's difficult. Okay, so Fibonacci, and your problem is that given you need to find a minimum sum such that sum to k. Okay, so for k, answer is 2. For k7, answer is 2 because 2 plus 5 is 2, 7. And the 10 is 2 because 2 plus 8. And the 2 both and 8 are 7. And the 19, which is 1 plus 5 plus 13. And you can see k is very large. Okay, so simply speaking, if you write that rigorously, is that you can consider a set. Let's say you take a set, which every number is a Fibonacci, and potentially can be infinite, right? But let's say you get some upper bound n because your k is bounded. Okay, and your goal is to find a this a which is a subset of S, such that if you sum over all the element in A x, which is equals to k, and you want to minimize find it, you need to minimize A, right? So simply speaking, you need to find a minimum of A. Okay, the magnitude of A such that x belongs to A, sum is k. Okay, and yeah, so this is your goal. Okay, so when you naively think this question, this should be NP. This should be NP complete. The reason is that usually this is the same as so-called subset sum, and this is very difficult because you want to find the minimum of this A. So you are not solving just NP. You are not solving some decision equation. Actually, you are solving more difficult question. Okay, so the magical part is this Fibonacci. So this is not other number. This is Fibonacci. Okay, so this is the key. Okay, so let me just first describe the answer. Okay, so let me just this is very non-trivial, but maybe you can see the answer. Okay, you can see that 7, right, is 5 and 2. So the idea is that let's say you get 1, 1, 2, 3, 5, 8, right? So 7 is here. Okay, and then you can see that the answer will be you just take the Fibonacci number 5, which is closest to a 7. So you just minus this 5, and then you get 2. Okay, so this is the answer. And for this 10, you get 1, 1, 2, 3, 1, 1, 2, 3, 5, 8, and 13, and your 10 is here. Okay, so you just choose 8, and then you 10 minus 8, and then you get 2. Okay, and for this one, you get 1, 1, 2, 3, 5, 8, 13, 21. Okay, and your 19 is here, so you just choose 13, and you get 6. And so 6 here, you find a 5, and then you get 1. Okay, so simply speaking, you can see from here, simply speaking, the algorithm will be, very trivial. Just find the closest Fibo. Okay, so let's say, and k minus equals to Fibo. If k is 0, then stop. Otherwise, keep going. Okay, you can see this algorithm, right? For 19, you first find the nearest, very close, the closest Fibonacci, and you get 6, and you find the closest Fibonacci, and you minus, you get 1, or you get 0, right? Okay, so this is algorithm. Okay, so let me just see the code, and once we get it, then let me just give the proof. Okay, so the idea is that you start from 0, 1, and you need to first find this one, right? You need to first find this line. So basically, you need to find the first Fibonacci which is larger than your target. Okay, so if array -1, the final one is less than k, you just append it. And if the final one become k, then you return 1. This is the optimal case if your k is already a Fibonacci number. Okay, you define answer to be 0 and the j defined to be length array minus 2. Okay, so the reason is that we start from here. Okay, we start from this 13. And if array j less or equal to k, then k minus equal to array j, and the answer plus 1. This is the first step, right? You find the closest small Fibonacci number, which is smaller than u. Otherwise, that your j minus equal to 1 to find another one. Okay, return answer. Okay, this is very fast. And this is a key point that you can solve this problem. Okay, but the reason is why. Okay. Okay, so now let's give the proof. Okay, I think this is the difficult part that most of people solving this question. They just give you the answer, but they didn't tell you why this is true. Okay, so our question is that why this is true. So why we choose the closest Fibonacci number. This is not trivial to see. So my idea is that I can only prove by induction. So let's prove by using the induction. Also, the idea is that let's say this is your k, and then this is your fn, and then maybe fn minus 1, and then maybe fn minus 2. And then let's assume that our algorithm will always give the shortest summation from 0 to k minus 1. Okay, up to here. Okay, so that means that this region is already, let's assume that our algorithm is already correct. Okay. And our algorithm will always choose fn as our first point, right? So I can write k plus fn. Notice that fn and fn addition will be fn plus 1. And if k is equal to fn plus 1, then I just choose 1. So in this case, that k minus fn must be something which is less than fn minus 1, right? So k minus fn always be something which is less than fn minus 1. Okay, so will be something here. Okay, here. Okay, and we claim that we use our algorithm. Okay, and we get the shorter we get the results. Okay, so another reason. So this is okay. So once you do this, and then you can run our algorithm. Okay, you can run our algorithm, and so it give you the shortest one. Okay. So let's suppose I didn't do this. I use k minus fn minus 1. Okay. So the fact is weird, right? So when I use k minus fn minus 1, fn minus 2 plus fn minus 1 is fn. So when k minus fn minus 1, then I will get something which is when I use k minus fn minus 1. That I will get something which is larger than fn minus 2, right? So I get something which is larger than fn minus 2. Okay, so I can write k in terms of x plus fn. Okay, so when I use k minus fn minus 1, then I get x plus fn minus 1, which are x plus fn minus 2. Okay, so this is the additional step, and this is additional step. This is additional step. Okay, and then if I use k minus fn, then I only get x. Okay, so if I run my algorithm, I only need to decompose x. But in this case, I need to decompose x plus fn minus 2. So I get additional terms here. Okay, so which means that this one is shorter than this one if you do the decomposition. Okay, so this is a proof. This is not important if you want to see the mathematical proof. This is a proof. Because when you use k minus fn minus 1, you need to you already get fn minus 2. And this term cannot get decomposed. So you can only decompose up to x. But in this case, you only need to decompose x. So this one is less than this one because if you minus fn minus 2, you will get additional 1 terms. Oh, sorry, if you minus fn minus 1, you will get additional 1 term. Okay, so this is the proof why this algorithm find the closest Fibonacci is true. Okay, see you guys next videos.